So now, you may recall this particular theorem from Unit 3. When we were talking about isosceles triangles here, I mentioned that at this point we can't really prove that a specific theorem like this is true because we didn't have the tools. Well, I don't know about you, ladies and gentlemen, but we've been doing a lot of material on the side here. We've done a lot of things with these sorts of, and now that we have these Chevians here, I think it's high time for us to go back and confront this boss here. That seems pretty fair. So, if two sides of a triangle are congruent, the angles opposite them are congruent here. So let's go ahead and sketch this out. So when you're doing something like this here, we want to be able to write this out as a proof here, okay? So, as always, we want to list out the givens, we want to list out our proof statement here. So in this situation here, right, so two sides of a triangle are congruent, so I'm going to call them A, B, and C here. So we are given the fact that AB is congruent to AC here. We want to show that angle B is congruent to angle C. So I want to show this here, given these two. Yikes. That doesn't seem to be very much we can do with this here. Note that, considering the theme of what we've been looking at for the past, 3 or 4 sessions here, it seems like congruent triangles is going to be very important. We don't have any here. So, as they always say, necessity is the mother of invention. We need congruent triangles. We don't have any, so let's create one here. So let's go ahead and create a set of congruent triangles in this situation here. So the best way to do this is just draw something else into this picture. So we're going to draw in a new thing. So I'm going to construct something like this here. I'll construct an angle bisector. I'll call this D. So this AD is going to be an angle bisector. It's going to intersect BC at a point D here. So I'm going to create an angle bisector here. So note that this is yet another example of using an auxiliary line in a proof here. So the first step of my proof will be this. So we're going to construct a segment AD with D on BC such that AD bisects angle BAC here. So, of course, some of you may be, shouting at the screen here, why can you do this? Well, if you have an angle here, right? If you have an angle, and each angle has a specific measure, and we know that an angle bisector splits it in half, there's only one such line or line segment that you can draw that will actually do this here. If you try to draw a second segment that also bisects an angle like the first one here, you can actually show that those two segments must be the same. So, we can mention here, this is true since each angle has a unique bisector. Now, you're probably not going to be using this particular reason very much here, but in this case, this is a necessary evil. This is something we needed to use here because we didn't have the information. We had to create this here. But now that we have this angle bisector here, that makes things a lot easier here because now you can see what's going on, right? So we can say AB is congruent to AC from the given, right? So we know that here. So we can mention by the definition of an angle bisector. So notice that we're just gathering all our information here. We know angle BAD here is congruent to angle CAD, right? So that's important here. And we also have the good old reflexive property here. AD is congruent to itself, right? By reflexive property. Okay, so we have that. Thus, so now it looks like we got side angle side here. We can put this together. Thus, triangle BAD is congruent to triangle CAD by side angle side. So we can mention side angle side here, right? So that's something that we've established as true. Thus, now we know B and C are corresponding parts, so we can finish it off. So we can say angle B is congruent to angle C since corresponding parts of congruent triangles are congruent. Okay, so notice that this theorem here works out really, really well. And if you can recall, this is what our theorem originally said here. If two sides of a triangle are congruent and the angles opposite them are congruent here. This is going to be really important here. So you want to make sure that you get this sort of thing down. Okay? One important thing about this, ladies and gentlemen, is that this theorem here, you have to make sure you write this out in full. this theorem here, even though it's really important, this theorem here we should just write out in full to make sure we know what's going on here. And you're going to see why we actually had to write it out in full when we come back to this in the next lesson here. But as you can see, this one works now, so you don't have to do this. You can just simply utilize this theorem here, and this is going to be very, very valuable to you in the future.